So this is going to be a three-part video. The first is going to deal with probably one of the easiest parts of Module 7, and then we're going to deal with some speed of light issues in the second section, and then lastly we'll talk about electron configuration. So let's look at the easy part first. The good news here is that some of this stuff you are already familiar with. So, like for example, our first objective is to state the three particles found in an atom, where they are located in the atom, and then how they relate to each other. And already you can probably tell me that you know that there are electrons that are in orbit around the nucleus of an atom, and inside the nucleus are protons and neutrons. If you don't know that, that's okay, because it's pretty simple to get your mind around, but some of you will already know about that. The second part, the second objective, is that if I give you a neutral element, all I mean by that is if I say the carbon atom or the hydrogen atom or the phosphorus atom, whatever it is, if I give you an atom, I want you to state the number of protons and the electrons that it has associated with it. And that's going to be read straight off the periodic chart of the elements. There's nothing you're going to have to memorize about that. That's just going to be reading it. And then the last one, which involves a little bit of math, but it's really, really simple addition and subtraction math. I'm going to give you an isotope of an atom, and I'll explain what an isotope is in a minute. And then from there, you're going to determine the number of protons, neutrons, and electrons that are in that atom. And then we'll have a quiz, and that will be our first chunk here. The second video will deal with the wavelength and the frequency of light and have the energy that they contain, and we'll talk about that. And then the last thing we'll get to in a video after that will be predicting the electron configuration in orbitals around the atom. So let's go ahead and start with the easy part. We're going to look at the parts of an atom. So when we talk about the particles found in an atom, there are three things that you have to pay attention to. And the good news is you do not have to know the mass of any of these particles. It would be helpful to you if you knew that the neutron is a little bit more massive than the proton, but you don't have to remember these actual numbers. Matter of fact, you can remember them quite simply. You can say that the electron, in comparison to the proton or the neutron, it virtually has no mass. You see, the proton has a mass of 1 atomic mass unit. Technically, it's 1.0073, but let's just say it's 1. Well, look at how small the electron is in comparison to that, 0.00055. So for all practical purposes, these electrons, they're not going to add anything to the mass of that atom. So all the mass of the atom is going to be located in the nucleus, which houses the protons and the neutrons. All right, let's go back up here to the electron. What you do need to know, you don't have to know the mass of it, but you do need to know that an electron has a charge of -1 and that it's located outside the nucleus. We'll study about that when we talk about the Bohr atom again, and then finally the quantum model. But know these three things, that it's outside the nucleus and it has a charge, and that charge is -1. Similarly, but opposite, the proton has a mass, we're going to say basically of 1, and its charge is +1, and it's located within the nucleus. You need to know all of those things. The proton has a mass of 1. Don't have to worry about the 0.0073, but it has a mass of 1, and it has a charge of +1 as opposed to -1, and they're located within the nucleus. The thing you need to know about charges is that like charges repel one another, and opposite charges attract. So for example, an electron and a proton will actually be attracted because you have a charge of -1 attracted to a proton of +1. If you have two electrons, they're both going to have a charge of -1, and they are going to repel each other. Just like if you have two protons, they're going to have a charge of +1, and they are going to repel each other. Lastly, the other element, or the other particle found in an atom in the nucleus, is a neutron. And like I said, you don't have to remember all of the mass of this. Basically, remember that it has a mass of 1, just like the proton, but it's a little bit more, because somebody eventually will ask you, if you have a proton and a neutron, which one weighs more? And the neutron actually weighs a bit more, but you don't even have to say how much more. The interesting thing about the neutron is it has no charge to it. It's a charge of 0, but it's located with the proton in the nucleus. So that is what you need to know about the 3 particles found in an atom, and you need to memorize that the electron is located outside the nucleus, and it has a charge of -1, and it virtually doesn't contribute any mass to the atom. The proton is located within the nucleus, and it has a charge of +1, and it has a mass of 1 atomic mass unit. The neutron, it's located within the nucleus with the proton, and it has no charge of 0, and it has basically a mass of 1. So one of the things that we talked about in, I don't know, a few weeks ago, we did mention that 1 atomic mass unit equals 1.66 times 10 to the -24 grams. I don't believe that number is going to come into play at all in this module, but what I'm just pointing out is that we have simplified this a great deal. We said a proton has a mass of 1 atomic mass unit. Well, that is a whole lot more friendly to work with than to say that the proton has a mass of 1.66 times 10 to the -24 grams. So here we are as chemists, we're actually doing you a favor by simplifying things. So that is the first objective already out of the way. All right, so our second objective is this. If you're given any neutral element, and like I said before, like I just say, let's say that I talk about the carbon atom. And I want you to look at the periodic chart of the elements, and I want you to tell me, based on what you see there, the number of protons and the number of electrons. All right, I'll show you how we go about doing that. All right, for example, let's say that I give you the atom of sodium. All right, if you look on the periodic chart of the elements, you will notice that sodium, it has is the number, it's the 11th atom in the series. It's the 11th, okay? And the good news is, if you want to know how many protons there are in a sodium atom that's neutral, it matches exactly its atomic number. So this has a number of 11, so the number of protons would be 11. And because it's a neutral, in other words, it's not sodium with a plus charge or a minus charge, it also has to have 11 electrons. And so you can read right off the periodic chart of the elements the number of protons and the number of electrons. They will always be the same, and they will be the atomic number, and that's assuming that we're talking about an atom that is not an ion. It's not a positively or a negatively charged particle. All right? Don't worry about the mass yet. That's actually the atomic mass down there, but just focus on this. All right, let's look at another example. So carbon. How many protons and how many neutrons, how many protons and how many electrons are there in a neutral carbon atom? Well, you're just going to go right to the periodic chart of the elements, and you're going to notice that carbon has the atomic number of 6, and that means that there are 6 protons and 6 electrons. Simple, right? All right. Let's go one more step. How about nitrogen? How many protons are there on nitrogen? Boom, you got it. Yeah, 7. How many electrons? 7, just like that. All right? So that's how you determine the number of protons and the number of electrons in a neutral atom. The neutrons, determining their number is a little bit more difficult. Not a whole lot, but a little bit more difficult. We're going to have to talk about what an isotope of an atom is, and that's our next step. So an isotope is always referring to a specific carbon atom or a specific nitrogen or a specific uranium atom, not just to the carbon atoms that you in general find that make up, the world around us, but a specific one. And it turns out that carbon, obviously, in order to be carbon, it has to have 6 protons and it has 6 electrons. The number 6 defines that it's carbon, because in any other atom that has 6 protons, by definition, is carbon. But you can see that some carbons have different mass numbers. You can have carbon 12, you can have carbon 13, and you can have carbon 14. Now, if we average your average carbon atom that you'll find in nature, you will come up with an atomic mass of 12.011. And what that reflects is that some of these carbon atoms actually have an atomic mass of 12, others have 13, and others have 14. And the difference has nothing to do with the electrons or the protons, but the difference has to do with the number of neutrons. Now remember that a neutron weighs virtually the same amount as a proton. So if you would have carbon 12, you could predict that you have 6 protons and 6 neutrons because the mass is 12. 6 plus 6 would give you 12. But if you had carbon 13, well, somehow we have to come up with another atomic mass unit, and what that means is that you still have to have a 6 for it to be carbon, but it has 7 neutrons in it, and that's why it's carbon 13. And look at this wild guy here. He's still carbon because he has 6 protons, but it has a mass of 14, which means that you have 8 neutrons associated with that. And so when we talk about isotopes, we're not talking about the atomic mass that you see on the periodic chart, because that reflects the average of these in nature. And there certainly is not an equal number of these. Some of these have a vanishingly small percentage of the carbon atoms, and some have more, but the average is 12.011. But if you want to talk about a specific carbon atom that is an isotope, it could be carbon 12, carbon 13, and carbon 14. Now sometimes people think, well, really carbon 12 is the real carbon, and then these other two are the kind of oddballs, and they're not really carbon. It's not true. The way God put this stuff together, sometimes carbon has 6, sometimes it has 7, and sometimes it has 8 neutrons, and they are all carbon. They're not all completely identical because they have a different mass, but as far as the way they relate in a chemical reaction, they are interchangeably entirely with one another. All right, let's talk about the notation. Because we're talking about specific isotopes, we have to be really specific about the characteristics, and particularly the mass. So we could say that we could talk about a uranium atom, and we could talk about uranium-238. Well, this is what that means. That means that this uranium isotope has an atomic mass of 238. If you want to know how many protons and how many neutrons, well, you would go to the periodic chart of the elements, look up the atomic number. That will tell you how many protons we have. Take however many protons, subtract from that, or take that number, subtract from this 238, and that will give you the number of neutrons. Another way to write this would just be the symbol U, uranium-238, or sometimes it's written this way, the symbol U with the uppercase 238 there. That is how you write a specific isotope. So, what is an isotope? It's an atom with a varying number of neutrons. That doesn't ever affect the atomic number of the atom. That's always going to stay as 6, but this mass down here will vary. Protons and neutrons have an assumed mass of 1, so when you combine them together, they equal the atomic mass number. All right, now we'll go back to our simple example of carbon. So carbon 14, we're talking about this guy right there, carbon 14. Notice they don't list the 6 protons. They don't have to, because carbon by definition always has to have 6 protons, and because of that it also has 6 electrons. So you could write that carbon 14 or C-14, or you could write it the whole element name, carbon 14, and it has 6 protons, 6 electrons, and the way you figure out how many neutrons, you take the mass of it, which is 14, and you subtract from it the number of protons, and that gives you the number of neutrons. So now we just have a bunch of really simple addition and subtraction kind of stuff, where I give you an isotope, and you need to tell me the number of protons, electrons, or neutrons in that isotope. All right, let's try some examples. Let's look right off the bat at beryllium here. So I'm giving you the isotope beryllium-9. You need to know that beryllium, look up on the periodic chart of the elements and figure out what its atomic number is. That's going to tell you how many protons and how many electrons there are in it. So if you look at the chart, you'll notice that it's atomic number 4, and that means that it has 4 protons and 4 electrons. If you want to determine now the number of neutrons, I'll take 9 minus 4, and that will give me 5, and that means I have 5 neutrons for it. It's just that simple. Let's look at another one. Here is sulfur 32. So again, you got to go to the periodic chart of the elements and figure out what atomic number sulfur is. We know that the mass of this sulfur isotope is 32. So you're going to look and you're going to find that sulfur is element number 16, which means it has 16 protons, 16 electrons. And if I take 32 minus 16, I come up with 16 neutrons. All right, let's look at another one. If I do cadmium-112, I look on the periodic chart of the elements, find its atomic mass, and I find that it is number 48 on the chart, which means I have 48 protons, 48 electrons, and if I want to know the number of neutrons, I take 112, subtract 48 from it, and that will give me the number of neutrons. See? Nice, simple math. So I'm going to leave the rest of these for you to do in the notes, but that is how we figure out the isotopes. Okay, so we have gone through our objectives. You now will be able to tell me the 3 particles found in an atom. There are protons, neutrons in the nucleus, an electron in the orbit around the nucleus, and the electron has a negative charge to it. The proton has I should go back up. The electron has a -1 charge. The 1 is the charge. The proton has a +1 charge, as opposed to like a +2, and the neutron has no charge whatsoever. Given any neutral element, state the number of protons and neutrons, protons and electrons. All you have to do is read it right off the periodic chart of the elements. Whatever the element number is, that is the number of protons and that is the number of neutrons. Given the mass of any isotope, you ought to be able to determine the number of protons, neutrons, and electrons. So I will give you like carbon 14, you ought to be able to say that because carbon has an atomic number of 6, that it has 6 protons, 14 minus 6 would be 8 neutrons, and 6 electrons because they have to have the same number of protons and electrons. And then I leave the quiz to you. Okay, and that wraps up the first third of Module 7. Now, I didn't go into any of the history, which I find fascinating, and I would encourage you to read Wiley's book. You need to understand who Crookes was and his contribution. Basically, he discovered an electron. He called it a cathode ray. And you need to know Rutherford's contribution. He concluded that the atom is made up of mostly empty space, that the electrons orbit around the nucleus, and that the nucleus is vanishingly small in volume compared to the size of the atom. What I mean is that the atom has, if the diameter of the atom is, so the diameter of the nucleus would be so tiny you couldn't even see it with the eye. So vastly different volumes for the nucleus as well as the atom. And I think that will get you through the first part of Module 7. Next video, we'll go into light, the speed of light, the frequency of light, and the wavelength of light. We'll deal with all of that.